Okay, yeah, that recorded. Okay, so those who just joined, we're just going to go over a couple of examples that you should have already written down, but we'll go through the process again and just sort of follow that through. So you've got your notes from last time, should be the last couple of pages, okay, the last couple of examples. So prior to the questions that I asked you to sort of have a go at yourself. Okay, so let's get this shared. Nice one. Okay, so I should be sharing my screen, guys. Okay, so factorisation. Okay, so question in assessment or wherever you see it, exam, okay, will be simple as factorise, or they'll sometimes put something like factorise fully, or something along those lines, but it should be pretty obvious just by going off the structure of it. So if you see sort of trinomial, okay, so something that's in the form ax squared plus bx plus c, you know it's you're going to start looking at factorising it, simplifying that down and putting it in another format. Okay, and by format I just put it in a different structure. So we're putting some parts into brackets and we're tidying it up. Okay, so remember here, the a and the b and the c are just numbers that we can substitute in there. Okay, so they're just putting a space where we would see a number. Okay, so I'll show you an example of that. So if we do 1, you should have already this copied down, so you don't need to do it again unless you just want to practice. Okay, so that is in the formula, in the format of ax squared plus bx plus c. Okay, we've got an x squared term. Okay, so effectively that's writing like that, 1x squared. Okay, but we don't, when we're doing algebraic functions, if there's only one of them, we don't write the number 1. Okay, so that's why you don't see it. Okay, so that's effectively 1x squared. So there's one of an x squared term. Okay, then there's 5x, then there's 6. Okay, we're looking to factorise that. So we're looking to simplify that and put that into brackets. Okay, so we're wanting to put brackets like that. Spend a lot of time breaking up brackets, so this is really just putting it back into brackets. Okay, so first thing that I ask you to do every time is just write out CDT. Okay, so that just gets it clear in your head what your process is going to be. So the first thing you want to check for in everything you see, is it a common factor? Okay, so is there any common factors we can remove there? Okay, and remember that could be a number or letter. Okay, but in this time, there's no common factor there. Okay. The D stands for difference of two squares. Okay, and that's a specific form of x squared minus and then a squared term that you're looking for. Okay, and we practice quite a few of them. So if you don't recognise when I say difference of two squares, go back over last week's stuff or 2 weeks ago, just refresh yourself in that. Okay, so difference of two squares, it's not a difference of two squares. A difference of two squares wouldn't have an x term in it. Okay, so very quickly you can sort of pick out. Okay, so it's not a difference of two squares, it is a trinomial. Now that CDT seems pretty obvious in this instance, but stick with it because it will become useful. Okay, in some examples. Okay, so trinomial, and that's the only thing we're basing it on. So we're no common factor, we're no difference of two squares. It's as simple as we need to start with. Okay, and then the process, we're looking for something that adds together to make the b term. Okay, in this case 5, and multiplies together to make this c term, in this case 6. Okay, so adds together to make b. Okay, or multiplies together to make c. Okay, and those letters come from here. Okay. Okay, so adding together to whatever's in front of the x, multiplying together to make whatever's in front of the c. So start with the multiplication. Okay, we're wanting to reach 6. Okay. Very importantly, remember to put the sign. Okay, you can even write it here. So when it's a positive, even just put the positive so you remember to do that. Okay, just getting good habits. The add will be +5. Again, good habits. So what do you multiply together to make a positive? It can be 2 positives or 2 negatives. Okay, so when we go through this, 2 numbers that multiply together to make 6, we're looking for either 2 positive numbers or 2 negative numbers to make positive 6. Okay, so going through all the factors, 1 and 6, 2 and 3, nice and easy. Okay, that's a full lot of them. We are looking for 2 numbers that add together to make 5. Again, nice and easy, 2 and 3 make 5. Okay, you can even go as far as writing +2 and +3. Okay, because 2 positives make a positive. Okay, again, that's just a good wee habit, just so you're pulling that through. And it's a case of taking these numbers, putting them in each of the bracket, and then breaking up that x squared as well. Okay, so in the brackets, we've got our, sorry. Okay, we've got our x's. Okay, so we split up that x term. Okay, we're +2 and +3. Okay, and remember when you do this, if you've got a wee bit of time in the exam, you can double check this just by breaking up the bracket again, just to check if you're right. So you're just carrying out the FOIL. Okay, so remember 3 or 4 or 5 weeks back, we did FOIL. Okay, so first, outside, inside, last. Okay, so if we do that, just to check, okay, you don't need to do this step, but just to check, you've got x squared coming from there. Okay, your outside terms, x and 3. Okay, +3x. Your inside terms, your 2 and your x, +2x. And your lasts are, let's do that in yellow, these terms here, that's just +6. Okay, pulling them all together, pulling the like terms together, x squared plus 5x plus 6. Okay, does that equal that? Yes, we've checked it, we're happy, we move on, we forget about it. Okay, everyone comfortable with that sort of factorising? Okay, how about we do a slightly more complicated one? I'll throw in a negative sign just so we know what we're doing. Okay, so the example, x squared plus 5x minus 14. Okay, so the only real complexity here that I've thrown in, it's just this wee negative. Okay, and this again is just following your process and making sure you take that negative sign and you deal with it. Okay, so don't just forget about it and hope it goes away. Okay, found out the hard way in engineering that doesn't always work. Okay, so x squared plus 5x minus 14, always first step, CDT, no common factor, no difference to 2 squares, we are looking at trinomial. Just a good habit to get into, guys, okay? Adding together to make the b term, multiplying together to make the c term. C term is minus 14, b term is 5. Okay, to make a negative, you multiply positive and a negative, or flip that round, negative and a positive. Okay, just put these symbols there so you remember to do that. Okay, all the factors of 14, so we should be pretty good at this now. 1, 14, 2 and 7, 3 doesn't, 4 doesn't, 5 doesn't, 6 doesn't, and then we've got back to 7. Okay, so only 4 factors there, nice and easy. Okay, so we're trying to make positive 5. We can see it's pretty obvious which ones we're going to use. The trick is just making sure we get the right signs. Okay, so signs you're wanting to pull in are going to be that negative and the positive. So make sure you put negative, positive. Okay, So plus 7, negative 2 gives you your target of 5. Okay, brilliant. Perfect. Going back up here, split the x term, make that a wee bit neater. Split the x term, what was it? Minus 2 plus 7. Okay, that's that trinomial factorised. Okay, you also see it written as quadratic. Those two terms for us, for our sake, are just interchangeable. Okay. Again, if you want to double check that, x squared minus 2x plus 7x minus 14. Okay, does that equal that? Yep, we're happy. Okay, so just a wee bit more complicated. We're just throwing in a wee negative there. Nothing to worry about, just make sure you deal with it. Okay. Make sure you also double check that, because it's an easy one just to miss, especially when we're under pressure and we're working quickly. You sometimes miss symbols. Okay, everyone does it. Really common. Don't lose silly marks. Okay, perfect. So that's where we got to last week. So we got to that sort of format. Okay, so I'm going to throw in a wee complexity to it. Okay, annoyingly, and that is when we've got something in front of the x squared term. Okay, so remember, trinomial is written ax squared plus bx plus c, where the a, the b, and the c are just placeholders for a number. Okay, that number can be anything, 1, 2 trillion. Okay, hopefully you don't see that in the exam. It can be any number. So that a, b, and c can be any number substituted in there. So we're going to experience some equations, some formats, where we're going to have something in the position of the a. Okay, so when a is greater than 1, if you like. Okay, so the process of this isn't, it's quite quite complicated, because there's not one way of doing it. And this is the dangers of using multiple resources. Okay, so the way I'm going to show you is the way I like to do it. I think it's the easiest way. It's slightly different to what BBC Bite Size show you, and it's slightly different to what Dynamics Notes show you. Okay, and I've told you before, that's the sort of three notes that I use. Sorry, Frey, I missed that question. Sorry, Sandra, I missed your question. So your question was, Sandra, -2 and -3 for that first one?
No, the second one.
Oh, the second one, sorry.
The last one, yeah.
That one
You know,
there.
we've got 1, -2, 48, and +7. Do we not use -1, -2 in that? No.
It's -1, -2.
To go into 14 and to go
Oh, sorry, so like that.
multiplying. Do we not
Yeah.
use any of the negative numbers?
Okay, so I just split it up, so I've got the factors, and then
Right.
I sort of substitute in where the signs are going to be. Okay.
Right.
Because it all depends on this a value. So it's always, I use the sign required so we get to that a value. Okay, so if that a value was -5, then those signs would be the other way around. It would be +2 and -7. That
Okay,
still
thank
gives
you.
you -14, so it depends what's in this A. Okay, depends where your signs are going to go.
Okay, thank you.
So that makes sense. Okay. Try it again. So after tonight, just try it again yourself and just make sure it makes sense in your head, and if it doesn't come back to me, we can absolutely go through it. Doesn't matter what sign we use in each bracket. So let's go back to that. So Faye, do you mean if we had the brackets like that? The answer's no. Okay, we can do it either way. Okay, so that form there is the exact same as that. Okay, when you break the bracket up. Okay, so it doesn't matter which way around they go. Okay, as long as you get the right equation at the end. No, it doesn't. Okay, I'll pay more attention to that. Perfect. Okay, just make sure there's no one in the waiting room while I'm here. Cool, perfect. Okay, so as I was saying, we're looking at something like that. So we're looking at where there is something in front of that A. Okay, so don't worry the fact that some of the processes don't match. Okay, I'm telling you this not to scare you. I'm telling you this so that if I tell you how to do it, and then you go off and try and look at BBC Bite Size, you're not surprised when you're going, something not right there. Okay, so I'll talk you through my way. Okay, and we'll do a couple of examples my way. I will go on to BBC Bite Size and I'll talk through exactly what they're doing as well. Okay, and it's just a difference of organising. Okay, so we're doing the same thing, but we're getting to the same answer, but we're just doing it a wee bit more. This will make more sense. Okay, so let's put a form in that. 2x squared plus 5x plus 3. Okay, so there is a value there. Okay, remember when it's just x squared, it means there's a 1 in front of it, but we don't write the 1 in algebra. Okay, unless it's a single number. Okay, so 2x squared means there's 2 of the x squared terms, 5x plus 3. Okay, so we can't follow the exact same process. So we can't go straight to the c value and go what multiplies together to make 3. Okay, we need to think about this. We need to think about what we're doing with this guy. Okay. Oof. So what we need to do is follow the same process in respect of writing CDT. Okay, this is where common factors really help you out. Okay, so if you can take a common factor out of this, it makes life easier. Okay, and I'll have an example of one of them later on. Okay, if you don't take the common factor out, this sometimes gets really messy. You can still do it, but it sometimes gets really messy. Okay, so always write CDT. There's no common factor in this specific one, so I'll put a wee X beside it. It's definitely not a difference of two squares. Okay, so it's just a trinomial. We are going to write A and we are going to write M for add and multiply. But the multiply value we're going to use, okay, is going to be the 3 multiplied by the A term. Okay, so we're going to bring that A term, we're going to multiply that 3. So it's going to be 2 times 3. Okay, so what goes underneath your M effectively is A times C. Okay, and there, for this example, that's going to be 2 times 3. Okay, there's a 2 in the A position, and there's a 3 in the C. Okay, and that's obviously going to give us 6. So we're looking for factors of 6. Okay, I wouldn't usually write that under M. Okay, that's just a wee bit messy. I'm writing that for this example, but further examples we won't do that. Okay, so we're looking for multiples of 6. Okay, that's going to give us our pairs of terms, and then we're going to add them together. Okay, we're still going to add them together, and we're still going to try and make the B value. So A doesn't change, the target doesn't change, the target is still your b value. Okay, this is where it gets a wee bit messy. So firstly, let's do factors of 6. It's a positive, so 2 positives or 2 negatives, and I'll just put that in just for good habits. They're both positive, okay. Factors of 6 is 1 and 6, 2 and 3, 4 isn't, 5 isn't, okay, so back to that. What adds together here to make 5 that have to be both positive or both negative? Your answer is your 2 and your 3, okay. So both 2 and 3 are going to be positive. Okay, so normally we would take those factors now and we'd put them in the brackets and all would be well, we'd have 2x's and lovely. We need to deal with this 2x. Okay, so the best way to do it is we start our brackets with 2x and 2x. Okay, we're putting in our factors, which is plus 2 and plus 3. Okay. Okay, so instead of just x and x, we're going to put in 2x and we're going to put in 2x. Okay, now you might look at that and go, that doesn't make sense. If we multiplied out that bracket, you would have 4x squared at the front. Okay, and you're absolutely right. So we need to do one other step. Okay, and that's divide this whole thing by the a value again. Okay, so we're dividing the whole thing by this. Okay, this sounds really bizarre. It is really bizarre, but it's the simplest method. So we're dividing the whole thing by that a value. Okay, so that's very important. So whatever the a value is. Okay, so we're left with this. Okay, so we're left with bracket 2x plus 2, close bracket, bracket 2x plus 3 over 2. Now that looks messy, so we want to take away that bottom 2. So we want to look for common factors within these brackets to try and pull out. Okay, and that's sometimes quite difficult to see, but just follow the process. Okay, so we're looking for 2 on the outside effectively. So take these brackets separately. Okay, so I'm going to call that bracket 1, I'm going to call that bracket 2. Okay. So when we were looking at common factors, if we were looking at bracket 1, okay, which is 2x plus 2, okay, common factor to come out that would be 2. Okay, we can take 2 out of that and that simplifies that bracket, doesn't it? Okay, so we can take 2 out of that and the bracket becomes x plus 1. Okay. Now if we look at bracket 2 and we treat it separately, okay, bracket 2 was 2x plus 3. Okay, that doesn't simplify down. There's no common factors there at all. Okay, so there's no common factors with bracket 2. So we can't simplify that any further. So the only thing we can simplify is this. Okay, so we can simplify that term on the top of that. Okay, so I've just done that separately just to show you there. Okay, so put a wee box around that. Okay, so if we've got 2x plus 2, 2x plus 3 over 2, we can simplify that to 2x plus 1, 2x plus 3 over 2. Okay, so we've simplified that first bracket by removing a common factor. Okay, now if you've got multiplied terms up the top and you've got common number down in the bottom, but in the denominator, you can cancel out. Okay, so those 2's cancel out. Okay, this is not, it's not easy, it's confusing. Every time I teach it, I need to go back and look at it. So if you're looking at that and going, getting a wee bit lost, don't worry. Just take a wee bit of time to process it. Okay, so those 2's cancel out, and we're left then with a factorised term, x plus 1, 2x plus 3. Okay, and that's the final expression.
Can I just ask a question, if that's all right?
Yeah, of course.
Where does the 2 from the bottom come from? Like up at the top bit?
So this is part of the process. So it's not obvious, okay, and it's not, it's a process we need to do, and we're just taking it from the A term. So the bottom denominator of that fraction is just taken from whatever's in front of A, and
Right, okay.
whatever's in front of the x squared. Okay, so whatever's in front of this x squared goes in the bottom of that fraction. So when we do another example, it'll be a different number, it won't be 2.
Okay, doke. Yeah, that's fine.
Yeah.
Cheers.
Okay, so that's probably the best way to do this. I'll do another example and I'll do the exact same things, okay? And then I'll give you 10 minutes just to look over both so you can make sure you're tracking it, make sure you're following it, okay? So push that to one side. And let's have a go at term 4x squared plus 3x minus 7. Okay, so again, we're always looking out for ax squared plus bx plus c. A, b, and c in this case, just placeholders for a number, any number. Okay, in this case, 4, 3, and negative 7. Okay, must have felt generous throwing in a negative. Okay, so first step, as always, CDT. 4, 3, and 7, is there a common factor? The answer is no. It's not the difference of 2 squares, it's just trinomials. Okay, just keep going with that. I know it's never borne fruit yet. Okay, so A is going to be the B term. Okay, we're doing nothing to that B term. So A is just the target, and it's positive 3. Multiply is a wee bit trickier. So the multiply is a multiplication of A and C. Okay, in this case it's 4 times negative 7. Quite a big number, negative 28. Okay, plus and negative, or negative and plus. Okay, so how we get a negative number, you multiply a positive and a negative, or a negative and a positive. Okay, that's the only way. We can't do it any other way. So we're looking for factors of 28. So don't be scared that that's quite a big number. Okay, just think it and go through the same process. 1 and 28, obviously. Okay, does 2 go into it? Yes, it does. 2 and 14. Does 3 go into it? No. Does 4 go into it? Yes. Okay, so 4 and 7. 5, no. 6, no. And then we're at 7. We've already got 8, no. 9, no. 10, no. Okay. So those six numbers are all your factors. Okay, everyone comfortable with there from? Okay, remember this part. We are looking for two numbers that multiply together to make minus 28, but add together to make plus 3. Okay, so we're looking at those pairs of numbers. We're going to focus on this 4 and the 7, but we need to get the negative sign in the right place. Okay, so to make positive 3, we want to start with positive 7 and then take away 4. Okay, so that negative sign is going to go in front of 4, and the positive is going to go in front of the 7. Remember, they're two separate numbers. Okay, that's not an equation. Okay, so it's going to be -4 and it's going to be a +7. Okay, so we take those terms and then we follow that odd looking process. Okay, so set up some brackets. Okay, we're going to take the ax squared terms and we're going to split that over two brackets, but we're going to keep a the same. Okay, so we're going to keep that first number the same. Okay, then we're going to put in what we've just found out, so it's going to be -4, it's going to be +7. Okay, and then we're going to divide all that by the a term, in this case the number 4. Okay. Now we want to simplify that top line to see if either of those brackets, and we treat the brackets separately, okay, either of those brackets have a common factor that we can remove. Okay, so bracket 1, bracket 2. Okay, so we look at both brackets separately and we look for common factors. Bracket 1 has a common factor of 4, so let's simplify that by taking the 4 out the bracket. We do x minus 1. Okay, bracket 2 doesn't have any common factors, so that's as simplified as it gets. Okay, so 4x plus 7. Remember, that's all over 4. Okay, and you see where I'm going with this? Okay, top 4 and the bottom 4 cancel out, and we're left with our final factorised term. That's the fully factorised term. Okay. Okay, so I'm gonna give you, that's 20 to 7, so it's quite an odd process, so I'm going to give you until 7 o'clock just to walk away from your table for 5 minutes, then come back and then look through the first example we did and look through the second example you did and try and make sense of it in your head. Okay, don't worry if it doesn't make sense yet, we'll come back together and we'll go through a couple more examples. Okay, so 5 minutes away from your desk, come back, try and get your head around it. All right, so we'll come back at 7 o'clock on the dot. Okay, make it nice and easy. Any questions before break up? Nice one, guys. Confused? Okay, so I'm going to do a couple more examples, go through that same process. The next two be tiny bit more complicated, but it's the same process. Okay, and then we will do a couple of attempts ourselves. Okay, attempts at questions. Okay. Okay, sorry, the notes are all over the place. Okay, so if no questions, sorry, 2 seconds. No problem. Okay, so if no questions on the first two, I'll go on to the next one. Okay, same format. Okay, so 10x squared minus x minus 3. Okay, first things we're looking at things like the negative signs. Okay, so we just need to think, right, need to be careful with the negatives. Okay, let's look at or think about the format that we're using. Okay, so ax squared plus bx plus c. Okay, so that's just the format of a quadratic, of a trinomial. Okay, a is your 10, b is your -1. Okay, so remember in algebra, a 1 would be there, but we don't write that term.
Sorry, quick question.
Yeah.
See the A, B, C bit, does that never change then?
That's
Is that-
no. So the letters A, B, and C in this specific format. Okay, the
Yep.
letters A, B, and C are just there to show that a number could exist in that position.
Right, okay,
Okay.
that's fine.
So that's the format of a trinomial or a format of a quadratic. Okay, so
Right, no problem, thank you.
yeah, so that doesn't change. Okay, we'll see later on tonight. We'll throw in another letter and it'll throw that completely out the window. But for this, that doesn't change. Okay, so ax squared plus b plus c. Okay, so the a in this case is your 10, b is going to be -1, and c in this case, remember that negative, c is going to be -3. Okay, first thing we do, c dt. Okay, no common factors. We always need to check. It's not a difference of two squares, but we all need to check. Okay, as a trinomial, so we'll work through that process. We put our a in the m. Okay, remember the m is going to be the number in the a position multiplied by the number in the c position. So we're doing +10 multiplied by -3. Okay, so the multiplication is going to give us -30. Okay. So, Olivia, you've just joined. So we're taking this number here and this number here, and we're multiplying them together. So 10 multiplied by -3. Okay. The addition, that doesn't change, okay, so we don't need to multiply it or throw it away. Okay, that's just -1. Okay. Is everyone happy with both those figures? Okay, where that -1 come from, where that -30. Okay, so focus on the m. To get a negative, we need to multiply two numbers. One of those numbers has to be positive, one of those numbers has to be negative. Okay, so they can be in that format. So we're going to write all our factors out, going to be in that format. Okay, so same case, we go through it. 1 and 30, 1's always a factor. Okay, is 2 a factor? Yes, it is. 2 and 15. Is 3 a factor? Yep. 3 and 10. Is 4 a factor? No. Okay, is 5 a factor? Yes. Okay, 5 times 6 makes 30. Okay, and then you can just go 6, yes, we've already got it. 7, no. 8, no. 9, no. 10, yes, we've already got it. Perfect. Okay, so you can work all the way. Okay, so we're looking for two numbers here. One of them's going to be positive, one of them's going to be negative. At this point, we don't need to determine which one's which. That's what we're going to figure out now. So we've got a target. We've got a target, they need to add up to make -1. Okay, so that has to add together to make -1. Okay, one's going to be positive, one's going to be negative. Okay, so we're going to look and focus at this 5 and the 6. Which one's going to be the negative one? Well, it's going to be the 6, isn't it? Okay, and 5 is going to be the positive one. Okay, So we've got positive 5, we've got negative 6. Multiplies together to make 30. Correct. Adds together to make 1. Correct. Brilliant. Okay, now it's the muddly bit. Starting our brackets, 10x with plus 5 and 10x minus 6. And we're dividing it by whatever numbers in that A position. Okay, so we're dividing it this time by 10. Okay, so just staying consistent with our process. Next part we want to do is we want to treat both the brackets on the top line separately. Okay, we don't want to treat them independently. We want to see if there's any common factors that come out. So we want to simplify whatever's in that bracket. Okay, so that will be number 1. That will be number 2. Okay, so bracket 1 is 10x plus 5. Can we take out a common factor? Is there a common factor between 10 and 5? Yeah. Okay, the number 5 multiplies by 1 to get 5, and it multiplies by 2 to make 10. Okay, so we can take out 5 as a common factor. Oops. Oh, sorry. Okay, we've taken 5 out as a common factor. Okay, so now that's sort of where we ended it in the last couple of examples. So one bracket we could simplify, the other bracket we couldn't. But in this case, when we look at the second bracket, is there a common factor between 10 and minus 6? Okay, answer yes. Okay, so remember we're treating them completely independently in the first bracket and the second bracket. So between 10 and minus 6, we can take out the common factor of 2. Okay, and now it's just a case of tidying up. So on that top line, we've got 2 brackets with common factors outside them. What we can do with all those expressions is we can just sort them and get our like terms. Okay, so we're looking for like terms. Okay, there's a 5 and a 2. Okay, we can bring that over there, and they multiply together. Okay, so they're going to multiply together when we tidy that bracket up, when we tidy that top line up. So it becomes that. Okay, now you can see what we can do. We can cancel out the top line and the bottom, and we're left with a fully factorised expression. Okay, so believe me when I say this is as complex as one of these factorizations is going to be. Okay, that will push you in an exam situation. Okay, could come up, potentially come up. If you work through that process, get that, be very, very happy. All right. So our final fully factorised term, x plus 1, 5x minus 3. Oops. Hold on there. I'm missing a 2. Sorry guys. Sorry. There's a 2 in there. Then I took out the common factor. See how easy it is? Okay. It's easily done. Be very careful. The only reason I picked up on that is because I tried to double check it in my head, and I tried to make 10x squared, and I had x and a 5x, and that would make 5x squared. So I seen immediately. Okay, so it's little things like that if we can start picking up. Okay, that takes a wee bit of practice when you get used to it, going through it, but that's a quick double check. All right, so I missed out that 2, guys. Okay, when I took out that common factor for the first bracket. Okay, so it should be 5 bracket 2x plus 1 close bracket. Okay, and then all the way through. Okay, so your final brackets, 2x plus 1, 5x minus 3. Okay, that's really is as hard as it gets. Remember, you can double check that. So we have broken brackets like that before. Okay, so it's just following through, following through your foil. Okay. So if we were to check that, okay, and break that up, 2x times 5x, 10x squared, but outside, okay, so your 2x minus 3, okay, which would be minus 6x. You've got your inside, which is 1 times 5x, okay, plus 5x. And then you've got your lasts, 1 and minus 3, okay, which is minus 3. Remember, we're collecting the like terms, and we should end up with 10x squared minus 1x. Okay, remember in algebra we don't write the 1, so just minus x. Okay, minus 3. And thankfully that's the same. Okay. Okay, that should equal that. Okay, so remember there's always that opportunity at the end just to double check. Okay, just to double check that you've done that process. Okay, I'll do one more. Similar. Okay. So we've got it in our heads, and then I'll let you do a couple. We'll come back together, then I'm going to show you the BBC bite-size method, and we'll talk through exactly what they're doing differently to mine, so that if you ever do need to recheck and you can't find this video or whatever reason you don't understand your notes, you've got a wee other resource there. Okay, so we'll make sure we do that. Sorry, I've missed something in the chat there. Aha, Abby, you picked up on me. Good. Sorry I missed that. Thank you. If only I kept the chat. I'm going to leave this chat open actually. Have it there. Perfect. Well spotted. Okay, so another example. 8x squared plus 10x minus 3. Doesn't look very good, does it? Minus 3. Okay. I'll write this above, you don't need to. Okay, so A, B, C. Okay. What topic are these classed under? Factorising. Okay, so I'm just answering Faye's question there. What topic? So they're under factorisation. Okay, as hard as they come. Okay, so CDT, no common factor, no difference of two squares. Okay. A plus 10, put the B plus there if you want. Then the M value is going to be minus 3 multiplied by 8. Okay, so the M value is going to be minus 24. To get a minus, plus or minus, minus or a plus.
What does the A stand for again?
Here. That's
No,
just,
sorry, the A and the M,
oh sorry, add.
and then multiply.
So remember, yeah, so remember when we, don't be confused with the fact that we're multiplying two numbers together to get this minus 24 at the start. Okay, what this M signifies is we're looking for the factors of it, so we're going to make all the multiplication pairs, okay, and go through it, and that's what we're looking for. So two numbers that multiply together to make minus 24. Okay, so that's what the M stands for. M stands for multiply, A stands for add.
Okay.
So
Yeah.
two numbers that multiply together to make minus 24 and add together to make plus 10. Okay, so minus 24, don't know why I put minus there. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so again, remember, let's get really good at these times tables. As daft as that sounds, just practice them. Okay, it makes your life a lot easier. 5 doesn't go, 6 does. Okay, but we've already got that there. Okay, so two numbers here, add together, sorry, multiply together to make minus 24, but add together to make plus 10. Okay, so we're looking at that. One of these numbers has to be positive and one has to be negative. Okay, if you're looking at that, and we've done a couple of these now, okay, we're sort of picking out numbers that are getting close to positive 10. Okay, and we see the 4 and the 6 and go, the 4 and the 6, if we added them together, it does make positive 10. But we need to remember one has to be a negative. So be very careful when something like that happens. Don't immediately go, 4 and 6, boof, put that in. Okay, be very careful. And that's why doing this step is valuable. Okay, that's just a wee reminder to yourself that one has to be negative and one has to be positive. Okay, so 4 and 6, if they were both positive, does make plus 10, but if one of them's negative and one's positive, then there's no way that happens. 3 and 8, no, doesn't work. 12 and 2, now we're getting somewhere. Okay, so if we had a positive 12 and we take away 2, we're going to get positive 10. So that's the one we're wanting. We're going to have positive 12, negative 2. Okay, remember they're separate numbers. Okay, so if we had positive 12 and negative 2, we get our target, plus 10. Okay. You can see how there's wee bits of levels of complexity. Okay, so just be very careful, don't panic. Okay, so we're taking negative 2 and we're going to take plus 12 and we're going to do that process again. Okay, so we're going to create brackets. We're going to put 8x in both of these brackets. And then we're going to put minus 2 and positive 12. Then we're going to divide it all by this number. And then we follow the same process. Okay, so we look to simplify both brackets independent. So let's simplify 1, and then let's look at 2 and simplify that one. Okay, simplifying 1, is our common factors there? Yes, there is. Superb. Okay, let's take out that common factor, which in this case is going to be 2. And let's get this right this time. Minus 1, don't know what that giggle was. Okay, so 2 is a common factor there. Then we're taking that other bracket, 8x and plus 12. What's the common factor there? Okay, what goes into 8 and goes into 12? Answer is 4. Okay, so be careful there because we could also write the number 2. So the number 2 goes into 8 and the number 2 goes into 12. Okay, but you're looking for the highest. So the highest possible number that goes into both of those terms. Okay. Okay, so the number 2 does go into 8. Okay, so 2 times 4 goes into 8, and 2 times 6 equals 12. So 2 is a factor. Okay, but we're looking for the highest. Okay, so make sure we're the highest, always the highest. Highest common factor between 8 and 12 is going to be the number 4. Okay. Okay, it leaves us with that. And we're just going to tidy this up. Okay, so remember that top line is just 2 times that bracket times 4 times that bracket. Okay, so we can tidy that up by doing the 2 and the 4. Okay, effectively collecting like terms, but in a multiplication sense. That 2 and the 4 becomes 8. Okay, that 2, that 4. Okay, we're just tidying it up, that top line, that becomes 8. Okay. We can cancel those terms out. Okay. We're left with 4x plus 1, 2x plus 3. That is your fully factorised term. Okay. Okay, remember this is factorisation at its very hardest. Okay.
See, in like an exam, how would you like? How do you know that that's like? How would they word the question?
Factorise fully.
Right. Okay. So if you got like a normal trinomial, what would that say? Would that say something different? I take it.
So that would still be factorised. So if you see the word factorised, you're doing that sort of process, and you're
Right. Okay. Cool.
putting up. So if there's nothing in front of the x squared term,
Yep.
then happy days. Then it's you're still doing your CDT for both. You're doing it in M.
Yep.
Okay. The M is the more basic one where it's just the term which is in the C position.
Yeah.
Okay. So when there's something in front of that x squared, you need to multiply that to get the sort of bigger term there.
Right. Okay. That's great.
So it's a wee bit
Thank
more
you.
complicated, and the process is a wee bit confusing. Okay, so I'm going to leave you. So if you go to okay, so pack 1, expressions and formula. It's terrible. Okay, so that comes up. So in this pack, in pack 1, unit EF, okay, should be page 26 and 27, okay, and we should be question 14 and 15. So let's just have a wee look. What the questions are. So page, what does it say, 26. oh, sorry, page 26 and 27. 27's here, 14 and 15. Okay, so 14 and 15. There shouldn't be any trick questions in there. I'm not trying to trick you. So let's do a couple each question. Okay, so what's the time? 7:30. So let's have a go at A. And G. Let's just go with that. Okay, so factorise the following. Called it quadratic trinomial, don't worry about it. Okay. We've used the letter Q here, don't be put off with that. Okay, it's still in that format. So it's just try to throw you a wee bit. We're just using Q instead of X. Remember, that's just a variable. Okay, that just indicates a variable, so Q is just indicating some sort of thing that varies. Okay, so don't overthink that. It's still in the term A something squared plus B something on its own plus single number. Okay, so if we go to that, I'll give you, let's say, 15 minutes. Take 15 minutes, try and do those two. If you can fit in any more, okay, feel absolutely free. Okay, so come back at 7:45. Which is really sad. Okay, so what they've done, okay, is collect this term and this term, remove the common factors. So looking at that, okay, so I've written that out. Okay, they collect these two terms and they collect these two terms. Okay, and then they treat them separately and remove common factors. Okay, so they'd remove 3x from that, and they remove 2 from that. Still a plus sign in there, so. Okay, so that's what that step is there. So they're going from this line, it's just taking this, taking the common factor, taking this, taking the common factor. Okay, so they're effectively doing a left and right. Then they're essentially collecting that term and that term together to make a new bracket. Okay. And they're saying they're the same, so they sort of come together. So effectively you're joining like terms. So because these two brackets are the same, we can add that 3x and 2 together. Okay, so because it's a like for like term, essentially you're collecting like terms. Okay, that's why you get 3x plus 2 in a bracket, then x minus 3. Okay. Got to actually share that. Okay, so they've got this line here. Okay, so you're collecting like terms. So essentially, you're collecting x minus 3 terms. Okay, so that term and that term is the same. So you can add them together. and it gives you that. Alright. I think that's just a wee bit messier in the way we report through it. Okay. But because it's on BBC Bite Size, and I know a lot of people use BBC Bite Size, thought I'd just make sure that I'd cover that. Okay. So what I'm going to do is go through that question, but use my technique. Okay. So that you've got that to go side by side. Okay. That makes sense. So if you write at the top of this example, just BBC Bite Size example, okay, or just something to that effect, and say differs from what you see on the website. Okay, and just put a wee star beside it so you know when you look at that, if you're looking at different resources and pulling different things together, you know that that's going to be different. Okay, and you can even put refer back to video, and it will be a wee explanation on it. Okay, so let's do our technique, the one that we've been doing all tonight. Okay, on this, and then just tick that off. Okay, so let me just write that out. Because there's no easy way of doing this, and that's why there is so many different techniques. So it's ugly maths, if you like, because it's just trying to get to an answer, but by throwing a lot of different processes that sometimes just don't meet in my eyes. Which is odd for maths, because maths is usually very structured. Okay, so let's go through the process we've been doing all night. Okay, so you've got it. Okay, so remember to put BBC Bite Size example here. Okay, so first thing we want to do is CDT. Common factors, no. Difference of two squares, no. Trinomial, yes. Okay. Then we're going to do the add and multiply headings. Okay. The add is going to be your bx term, minus 7. And your multiply is going to be 3 multiplied by minus 6. Okay, and it gives you minus 18. Okay, so A times C, same so far. Then, instead of writing out every single sum, to make a negative, you multiply a positive and a negative, or a negative and a positive. Okay, and then we look at the factors of 18. So 1 and 18, 2 and 9, 3 and 6. Okay, so looking at that straight away, we can see it's not going to be 1 and 18 or 3 and 6. That just can't, there's no way we can do that either way. Okay, what it's going to do is we're going to use the 2 and the 9, and we're going to make sure we're using the right symbol, and we're going to make the target of minus 7. Okay, so we take these two numbers, 2 and 9, we want to make minus 7. Okay, so what symbols do we need? Well, the 9 needs to be the negative, and 2 needs to be the positive. Okay. So, wee bit neater so far. Okay, so we're taking those numbers and we're putting it into the format. We're taking the 3x plus 2 minus 9. Okay, and we're dividing that with whatever in front of this x squared. So we're dividing that by 3. Okay. Then we treat each of the brackets same. Okay, so we want to bring out common terms. So on the left hand bracket, the 3x plus 2, there's no common. Okay, There's no highest common factor. There's no common factor with 3 and 2, other than the number 1. Okay, so that bracket stays the same. The right-hand bracket, 3x minus 9, the highest common factor there is going to be the number 3. So we can remove 3 from that bracket. Okay, then we're dividing that by 3. That 3 and that 3 can cancel each other out. Okay, so we're left with the brackets 3x plus 2, x minus 3. 3x squared minus 9x plus 2x. Okay, so we get to the same answer. We should. So we get to the same answer. Okay, I think the way we've been doing it is a wee bit neater. Okay, it's a wee bit more structured. Okay, so there's an actual process we follow. CDT, then we do our A and our M headings. We do all our factors for the M value. Okay, remember the M value in this case is going to be A times C. Okay, we create a bracket. To the brackets, we take out a common factor. We simplify that down. Okay. So I don't like doing that because it does, especially after 8 o'clock, really confuse matters or blurry the water. What you need to do with that is just go away, look at the process we've done tonight, really understand it, and that will then, when you compare that like for like in bite size, if you come to that in a month or 2 months' time when you're looking over that stuff again, then you'll know why that's different. Okay, I didn't want you to get to that point in 3 months' time, look at it and go, I have no idea what I'm doing. So I thought I'd put the BBC bite size in there. So don't panic that it's different. Just follow the technique we've been doing today. Okay, that process. Okay, so 10 past 8. Let's do one more thing. Okay, and it's about factorisation, so it makes sense. Okay, and it's the reason why I tell you to write CDT at the start. So I want to do a couple of examples that has more than one type of factorisation. Okay, so again, we worded the same in the exam. It will be factorised fully. Okay, you just have to be aware that it might have more than one type of factorisation in it. Okay, so more. Common factor. Okay, does the expression have a common factor? We can simplify by looking through all the terms. Can we remove that? Okay, and just make life easier for ourselves. Is there a difference of 2 squares? This is a very precise process that you follow if you see a difference of 2 squares. Okay, so an example of that would be x squared minus 4. Okay, that's a squared term. That's a takeaway sign. Okay, so it's a difference. So difference of 2 squares means it has to be a takeaway. And that's a square as well. So you've got 2 squares, and they're taking away one from the other. Okay, difference of 2 squares. So that was just an example of one. Okay, and then the T for trinomials. and that's what we've been working on tonight and just the week before October break. Okay, so just in that format, ax squared plus bx plus c. Okay, so that's the three in the order that you need to look at the expression. Okay, so if you see factorise fully or factorise, CDT is the first thing you write down. You're looking for a common factor, you're looking for difference of two squares, and you're looking for trinomial. Okay, so let's put that into an example. Okay, so it's quite a tough one. 3x squared minus 75. Okay, so we're going back, and that will be factorise. Okay, so that's your question. Factorise fully, and then you get given 3x squared minus 75. Okay, so you look at that, and if you didn't write CDT, you might be like, factorising, I know I should be doing something. There's no x term in the middle, so is that a difference of two squares? And then you'll trip yourself up, and you're like, ah. Okay, so always write down CDT. CDT. C, common factor. Is there a common factor between 3 and 75? Yes, there is. Okay, this is where don't expect you to know the 25 times table. Okay, but sometimes, you know, you should be able to pick that up quite easily. Okay, so 25, 50, they're quite nice round numbers. Okay, 25, 50, 75, 100. Or things like that. Okay, so being able to pick that up. So is there a common factor? Yes, the number 3 goes into both of them. Okay, so it might not be immediately apparent, but okay, let's take it. Let's try 3. 3 goes into 3x squared, and it also goes into 75. Okay, and it's 25 times 3 will make 75. So we've removed that 3. So we've done a common factor. Okay. Take the hint of that word fully. Okay, so that's that not completely factorised. Okay, that word fully is a clue that there might be an extra step. Okay, the extra step, if you look in that bracket, okay, you've now got a difference of two squares. So you've got a square term here. You've got a difference, okay, because it's take away. And you've got a square term here. Okay, so at this point we're ignoring the 3. We know it's there, we keep it handy. We're ignoring the 3, we're just looking in that bracket, and can we factorise that any further? Yes, we can. It's a difference of two squares. So we follow the process, so we keep the 3. Okay, first term. So the first square term, okay, we do plus second square term, and the first square term minus the second square term. Okay. Everyone, you don't remember how to do difference of two squares, look back, so it's just a week before the October break. Okay. Okay. So we've done the common factor, got it. Is it completed? No. Let's look at difference of two squares. Yes, there's a difference of two squares, tick. Okay, so it can only be a maximum of 2 out of the 3. So it can't be common factor, difference of two squares and a trinomial. That just doesn't make sense. Okay, it's going to be common factor and difference of square, common factor and trinomial. Okay.
See, in terms of like marking, how many roughly would this be worth? A question like this, like marks.
I can look through past papers, but I would say 3 marks.
Okay, that's fine.
1 for taking the common factor out.
Yeah.
1 for noticing it's a difference of 2 squares, and then 1 for getting the difference of getting that correct. All right. So
Right, no problem. That's what
Effectively,
it's
you get a mark for that 3, you get a mark for that bracket, and you get a mark for that bracket. Okay, so let's do the same process, okay, but in a different example. Okay, so example 2, the 3x, can't do x's there, 3x squared minus 3x minus 60. Okay, and the question will be factorised fully. Okay, first thing we want to do is write c dt beside it. Okay, c, common factor. Okay, pretty confident you'll pick up common factor, there's going to be the number 3. Okay, so brilliant, we can take 3 out of that. Okay, now if you looked at that and thought that's a trinomial in the format that I know, and then you tried to find all the factors of 3 times 60, you're going to be there a long time. All right, so that's why it's really important you do this CDD process. Okay, so we've been working all night on doing multiplying the A term and the C term. If you looked at that and went straight for that option, you'd be there a very, very long time. Okay, so let's take out the common factor, and we're left with x squared. We're left with minus 1x. Okay, but we don't write that one. And we're left with minus 20. Okay, so we've taken out the common factor, and we're left with a simpler trinomial now in that bracket. Okay, so now we go up back to our letters, the CDT letters. Okay, remember this question will say factorise fully or something to that effect. Okay, so is that finished, or do we still need to keep going? Well, the fact there's an x squared there tells me we need to keep going. Okay, so we'll know that 3 for a second, and we'll focus on that. Is it a difference of 2 squares? No, because there's 3 terms. Okay, is it a trinomial? Yes. We solve that in our normal process. Okay, so we're going to solve x squared minus x minus 20 in our normal A and M process. Okay, A and M multiply together to make minus 20, add together to make minus 1. Okay, to make a minus, you need a minus and a positive, or a positive and a minus. Okay, if anyone's not following, shout out and I'll just go over it again. 120 is a factor, 2, 10 are factors, 3 isn't, 3 doesn't go into 20, 4 does, 4 and 5. Okay, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 does, we've already got that. Okay, 2 of these multiply together to make minus 20. Okay, so they add together to make minus 1. Okay, so we need to use these signs. Okay, we need to be smart, we need to use these signs correctly to add 2 of these numbers together to make this minus 1. Okay, 2 numbers we are going to add together, it's going to be the 4, we're going to make that minus 5. Okay, so that's our factors, 4 and minus 5, it multiplies together to make minus 20, adds together to make minus 1. Okay, we can take those factors and we just put them in. Okay, so there's nothing in front of that x squared term, so it's x plus 4, x minus 5. We can't do anything else to simplify. Okay, those brackets are straight back to what they need to be. Okay. Okay, so put these 3 questions up. I'll give you 10 minutes, so I'll put these questions up. So give these a go. Okay. Okay. Get as far as you can. Let's say 15 minutes. We'll come back at 20. So we'll come back at 35 minutes past 8. Okay, we'll come back at 35 minutes past 8. I'll put up the answers, ask any questions in, and we'll call it a night. Okay, so get as far as you can in 15 minutes. Okay, so 10x squared minus 40, factorise that fully. Factorise 2x squared minus 36 plus 64. And then 3x squared plus 18x minus 21. Okay. Come back at 35 minutes past and we will go through the answers. Okay. Just wait till I get. Alright. So 35 minutes past, we'll go through the answers to them.